Hi everyone, this is Ms. Helms, and we're going to go ahead and try a couple of examples with the special right triangles, in particular the 45, 45, 90 special right triangles. So, starting with number 1, we know that we have a 45, 45, 90 triangle, so therefore we know that the sides are congruent since it's an isosceles right triangle. So knowing this, we automatically know why. Y has to be 4 since we're given one of the other legs is also 4. So to solve for x, we can use our shortcut, which we learned in the notes, knowing that this is going to be whatever the side length is times radical 2, and we'll get our answer 4 radical 2. But some of us don't remember that shortcut, and that's okay. So instead, what we're going to do is we're going to use the Pythagorean theorem to solve for this. So, knowing the side lengths, we have 4 squared plus 4 squared equals x squared. Well, 4 squared is 16, so 16 plus 16 equals x squared. So 32 equals x squared. Take the square root of both sides. Again, you can put this in your calculator and get a decimal approximation, or you can keep this in simplified radical form. So, the square root of 32. When you think about the factors of 32, we know that factors of 32 would be 16 times 2. Well, we know that the square root of 16 is a perfect square, or 16 is a perfect square, so the square root of 16 is 4. Left under the radical, we have 2. So x is 4 radical 2, which is exactly what we had just come up with. So you can take either approach. You can take the shortcut method, or you can use the Pythagorean theorem to solve. It's really up to you. So let's go ahead and take a look at example number 2. In example number 2, we're given the hypotenuse rather than the side lengths. But again, it's a special right triangle. It's a 45, 45, 90. So therefore, the sides or the legs are congruent since it is an isosceles right triangle. So instead of calling one x and one y, that can be kind of confusing. We're just going to call both of them x. You could call them both y. We're just going to use x in this video. So based on our shortcut, we know that if we just look at this value in front of the radical, that will be each of our side lengths. So each of our sides will be 6. However, again, some of you will not remember that, and that's okay. So instead, we're going to pretend like we don't know that shortcut, and we're going to set up the Pythagorean theorem. So, to set it up, we've got x squared plus x squared equals the quantity 6 radical 2 squared. Well, x squared plus x squared is 2x squared equals, well, 6 radical 2 squared, and I'm just going to do this on the right over here. That's just 6 radical 2 times 6 radical 2. Okay, well, 6 times 6 is 36, and radical 2 times radical 2 is 2. So this is really 36 times 2, which is 72. You could put that in your calculator, but you don't have to. You can always use mental math. Don't forget about that. So really, 2x squared equals 72. Now, to get x squared by itself, we're going to divide both sides by 2. So x squared equals 36. And to get x by itself, we take the square root of both sides, so x equals 6. So each of our side lengths is 6. Again, we didn't use the shortcut, and we still got to the same answer. So don't feel like you have to use that. There are methods to not use a shortcut, or you could use a shortcut. It's really up to you.